Hello everyone. Today we are going to discuss the problem union of arrays with duplicates. It is one of the problem from the top array problems list. So its difficulty is easy. So the question is you are given two arrays A and B. So simply we need to return the union of both arrays in any order. So the order is not necessary. So for the definition, the union of two arrays is a collection of all distinct elements from either of the both arrays or multiple arrays. So if any element appears more than once in one or both arrays, it should be declared only once in the result. The note is elements of A and B are not necessarily distinct. Note that you can return the union in any order, but the driver code will print in sorted order only. So the first example is they gave the input A and B. So 1 2 3 2 1 is A and B is 3 2 2 3 3 2. So if you see as per the definition, distinct elements from either of the arrays. So distinct elements from the A are 1 2 3, and from the B, if we compare with the distinct elements from the A, there are no distinct elements other than the elements from A. So the output is simply 1 2 3. That's it. So in the second example, we can see all the elements from the both arrays are distinct. So the output is 1 2 3 4 5 6. That's it. So the expected complexities before going into the approach and the logic or the code. Time will be n plus m. N is the length of A, m is the length of B. So length of A array plus length of B array is equal to total complexity, and space is also same. So we are going to solve this problem in big of n, but space as big of n plus m. So what is our approach? So our approach is we are going to use the line which is distinct elements or unique elements from the both arrays. So we know that set will store the only unique elements which were added to it. So the same concept we are going to use here. So we use a hash set, which is a set which is present in the Java collection framework. So the things we are going to use are a hash set, a array list for the output storing, and the two loops or simply the loops. So the steps we are going to follow is we declare a empty hash set to add the elements from A and B all into the set. So by doing, we can see here the step 1 is declare empty hash set. Step 2 is add elements from A into set. Step 3 is add elements from B into set. Step 4 is for the specific reason of the written type of the function they give, we declare an array list and copy all the elements or add all the elements from set into the list. So this list is going to be the output. So the same steps which we are write down here, so we are going to use them above. So first step is what? It is to declare the empty hash set. So hash set, what is the type of hash set? It is going to be the integer. So set, let us give the name as set. So is equals to. So next, we also declare the array list here only to keep all the things in place. So hash set for our core logic and array list for the pure purpose of the output. So what is the step 2? We add all elements from the A into set. So adding each and every element from A into set. So we need not to use any indexing here for adding. So just we can use a for each loop like int n from A. So this means one by one elements from A will be going to store in n iteration by iteration. So in that iteration particularly, what we are going to do? So if you see, for example, what are the set of values coming into the n with respect to the first example which they give. So we can see a contains 1, 2, 3, 2, 1. So these are the same values. So for first iteration, the value n is equals to 1 and 2 will be into this 3 and so on. So now we can see that what we need to do. We need to add into the set. So it is n. So again the same logic. One by one element from the B will go into the n. So set dot add again n. So again for another loop int n in the set, again add them into the list. So list, simply return the list as the output. So the sample test case is passed and the hidden test case is we can see all the test cases are passed. So now we need to analyze the complexities. So in the hash itself, we are going to add all the elements. Although it can't store all the elements because of the unique property, but we are trying to add. So it takes prox n plus m for the worst case possibility. N is the size of A array, m is the size of B array. So same goes for the array list too. So the final space complexity is big of n plus m. So coming to the time, we can say it is a single loop, so it takes big of n. Again this loop also big of n. Again this also big of n. So big of n plus big of n plus big of n. It is again 3 into big of n. So again constant into any number. Again it is n only. So finally the time complexity is, we can say, big of n n plus m. So they are going to be the time and space complexity of our logic which we wrote here. So for the expected complexities, big of n plus m was the time, but our code is still more optimized than the expected one. But coming to the space, it is as usual. So our code is a little better optimized in terms of time complexity. So this problem link is given in the description. Go and practice. Thank you for watching.